variables, linear regressions, eigenvalue, eigenvector application in two-port network. In this video, we are going to explain about linear regression of multi-variables and multi-dependent variables, that is multi-input and multi-outputs. Multi-input, multi-output matrix used in two-port network as ABCD matrix. Eigenvalue, eigenvectors of this matrix used in is explained. Y equal to a plus x1. It is a equation for one input, one output equation. Consider a system. X1 is the input, y is the output. So the equation is y is equal to a plus x1, where a equal to constant, that is offset, b equal to coefficients gain, x1 is equal to variables inputs, y equal to dependent variables, that is output. Y is dependent on x1. It is shown in figure 1. You see here figure 2, the equation is y equal to a plus x1 plus c x2. Multi-input, one output equations. X1, S2 are input, Y is the output. So it is called multi-input, one output equations. Y equal to A plus B x1 plus C x2, where A equal to constant offset, B and C coefficients gain, x1, s2 variables inputs or data inputs, y equal to dependent variables outputs or data outputs. Here y is dependent on x1 or x2 or both. Multi-input, multi-output equations. Y1 equal to A1 plus B1 x1 plus C1 x2. Another equation is Y2 equal to A2 plus B2 x1 plus C2 x2, where A1, A2 constant offset, B1, B2, C1, C2 coefficients gain, x1, s2 variables, that is inputs or data inputs, y1, y2 equal to dependent variables, outputs or data output. See figure 4. In this figure, x1, s2 are two inputs, y1, y2 are two outputs. y1 depends on x1, s2, y2 depends on x1, s2. So two equations we have to calculate. y1 is equal to a1 plus b1 x1 plus c2 x2. a2 y2 is equal to a2 plus b2 x1 plus c2 x2. Linear regression. Here equation one input, one output equation. That is one variable, another is dependent variables. Equation is y is equal to a plus b x1. If any variations in x1, it will reflect in the y. You see the table right side, first table, x1 and y. If x1 is equal to 1, y is equal to 1.25. If x1 is equal to 3, y is equal to 3.75. If x1 is equal to 4, y is equal to 5. If x1 is equal to 6, y is equal to 7.5. 4 samples are used. So number of samples equal to 4. We have to find A and B of the equation. How to find out? So before that one, we should know the summations of the equations. That is summation of y equal to n into A plus b into sigma x1. Summation of y x1 equal to a into summation of x1 plus b into summation of x1 square. In the second table, it is mentioned we are having two quantities, that is x1 and y. From that, we form the four quantities, another two quantities. In the last row, summations, number of samples 4. So, sum of x1 is equal to 14. Sum of y is equal to 17.5. Sum of x1 y equal to 77.5. Sum of x1 square is equal to 62. The matrix formation to find the A and B is first matrix n sigma x1, sigma x1, sigma x square, x1 square, into A and B equal to output sigma y x1. The same can be written like that. A and B matrix equal to n sigma x1 sigma x1 squared inverse into sigma y x1. The values are substitute and inverse and multiplications we have done. So A and B equal to 0 and 1.25. So the equation is y is equal to 0 plus 1.25 x1. Y is equal to 1.25 x1. Multi-input, one output. The equation is y equal to a plus b x1 plus c x2. Here x1 and x2 are variables. Y is dependent variables. That is, depends on x and x2. The y will be varied. The right side, you see the table x1, x2 and y1. The samples, 4 samples they are taken. x1 and x2 varying. y1 depends on the x1 x2 output result is there. See here, first is x1, if x1 is equal to 1, x2 is equal to 2, then y1 is equal to 23.75. If x1 is equal to 3, x2 is equal to 7, y1 is equal to 82.5. If x1 is equal to 4, x2 is equal to 10, y1 is equal to 117.5. If x1 is equal to 6, x2 is equal to 3, y1 is equal to 41.25. We have to find out A, B, C of the equations. How to find out? We have to find the summations, sigmas. Sigma y equal to n into A plus B into sigma x1 plus C into sigma x2. Sigma x1y equal to A into sigma x1 plus b into sigma x1 square plus c into sigma x1 x2. Sigma y x2 is equal to a into sigma x2 plus b into sigma x1 x2 plus c into x2 square. Now in the right side you see the second table. Various for x1, x2 and y summations we have found out. Hence, for number of samples is equal to 4, sigmas x1 is equal to 14, sigma x2 is equal to 22, sigma y is equal to 265, sigma x1y is equal to 88.75, sigma x2y equal to 1924, sigma x1 x2 is 81, sigma x1 square is equal to 62, sigma x2 square is equal to 162. The equations which we had seen here is formed as a matrix form. Matrix n sigma x1 sigma x2 sigma x1 square sigma x1 s2 sigma s2 sigma x1 s2 sigma s2 square sigma another matrix a b c. Multiply this one is the output matrix sigma y x1 sigma y x2. So abc of the matrix equal to matrix A n sigma x1 sigma x2 sigma x1 square plus sigma x1 x2 sigma x2 sigma x1 s2 sigma x2 square inverse matrix sigma y x1 sigma y x2. So the values are substituted and we found the inverse and multiplications. The final is matrix ABC is 0, 1.25 and 11.3. So the equation is y equal to 0 plus 1.25 x1 plus 11.3 x2. So here A is 0. So final equation is 1.25 x1 plus 11.3 x2. If you substitute these values x1 x2, you will get the y1 value. Multi-input, multi-output equation. The equation is y1 equal to a1 plus b1 x1 plus c1 x2, y2 equal to a2 plus b2 x1 plus c2 x2. That is, x1, s2 are variables. y2 are dependent variables. That means depends on x1, s2, y1 is varying. Depends on x1, s2, y2 also is varying. Right side of the table you see x1, s2, y1, y2 is given. Suppose x1 is equal to 1, s2 is equal to 2, then y1 is equal to 23.75, y2 is equal to 2.55. If x1 is equal to 3, x2 is equal to 7, y1 is equal to 82.5, y2 is equal to 8.9. If x1 is equal to 4, x2 is equal to 10, y1 is equal to 117.5, y2 is equal to 12.7. If x1 is equal to 6, x2 is equal to 3, y2 equal to 41.25, y2 is equal to 4.05. So, x1, s2 are variables, y1, y2 are dependent variables, that is depends on x1, s2, y1, y2 is varying. For equation 1, here two equations are there, so we have to find out separate equations. First we have to see for y1 as a one equation. Then we have to see for y2 as another equation. To find y1 equation, refer earlier slide. x1, s2, y1 are same. So y1 is equal to 1.25x1 plus 11.25x2. In the same way, we have to find y2 equation. In y2 equation, we have to consider x1, s2, y2. See the table. Number of sample equal to 4. Sum of x1 is equal to 14. Sum of x2 is equal to 22. Sum of y2 is equal to 28.2. Sum of x1, y2 104. Sum of x2, y2 207. Sum of x1, x2 81. Sum of x1 squared 62. Sum of x2 squared 162. From this table, we can find the y2 equation as we did in the earlier slide. So y2 is equal to 0.05x1 plus 1.25x2. Two equation now we got it. That is y1 is equal to 1.25x1 plus 11.25x2. y2 is equal to 0.05x1 plus 1.25x2. That means we can write the equation in the matrix form. Matrix y1, y2 equal to matrix 1.25, 11.25, 0.05, 1.25 into matrix x1, x2. Two-port network ABCD parameters. In electrical system, V1, I1, V2, I2 are voltage and currents of the system. V1 is in terms of V2, I2, I1 in terms of V2, I2. So V1 is equal to A V2 plus B I2, I1 equal to C V2 plus D I2. That is, if we form in the matrix form, matrix V1 I1 equal to matrix ABCD into V2 I2 matrix. So this matrix is called ABCD matrix. Consider the system which is a T network, that is Z1 is equal to 5 ohms, Z2 is equal to 5 ohms and ZC 3 equal to 20 ohms. The same network can be represented in terms of ABCD matrix. That is ABCD matrix is 1.25, 11.25, 0.05, 1.25. So V1 I1 is equal to 1.25, 11.25, 0.05, 1.25 matrix into V2 I2. Here note, no voltage current dependent source in the T network. So matrix A equal to 1.25, 11.25, 0.05, 1.25. Data input V2 I2, data output V1 I1. So V1 is equal to 1.25 V2, 11.25 I2. I1 is equal to 0.05 V2, 1.25 I2. Eigen value, eigen vectors. In the two-port network, V1 I1 matrix equal to ABCD matrix into V2 I2. Here, matrix A is 1.25, 11.25, 0.05, and 1.25. Determinant of A minus lambda I equal to 0, where lambda is equal to eigenvalue, I is unit matrix. So, eigenvalue for 1.25, 11.25, 0.05, 1.25 matrix is equal to 2 and 0.5. If lambda 1 is equal to 2, then eigenvector is V dash. V dash is equal to 1 0.067 matrix or 10 0.67 matrix, where x2 equal to 0.0667 x1. Here, A V dash is equal to lambda V dash. That is matrix A into eigenvector equal to eigenvalue into eigenvector. That is 1.25, 11.25, 0.05, 1.25 matrix is multiplied by eigenvector 1, 0.067 equal to lambda into eigenvector 1 and 0.067. Since lambda 1 is equal to 2, this value equal to 2 into 1 and 0.067. That is equal to 2, 0.134. If data input is eigenvector, then data output is eigenvalue into eigenvector. Not needed to multiply A by eigenvector. That is V2 equal to 1 volt, I2 is equal to 0.067 ampere. Then V1 equal to 2 into 1 equal to 2 volt, I1 equal to 2 into 0.067 equal to 0.134 ampere. In two-port network, ABCD parameters are calculated based on T network impedances, that is Z1, Z2, Z3, or linear regression method as we explained in earlier slides by varying V1 voltage and load resistance ZL. Here matrix A is 1.25, 11.25, 0.05, 1.25. V dash equal to 1 0.067. If we connect ZL, that is equal to 50 ohms, that is 1 volt divided by 0.067 ampere equal to 50 ohms. And V1 to voltage source and increase the voltage, it will follow eigenvectors for lambda is equal to 2. That is V1 is equal to 2 V2, I1 equal to 2 I2. If V2 is equal to 1 volt, then I2 equal to 1 by 15, that is equal to 0.06 ampere. Then V1 is equal to 2 into 1 volt equal to 2 volt. I1 equal to 2 into 0.06766 ampere equal to 0.1334 ampere. If V2 equal to 6 volt, I2 equal to 6 by 15 equal to 0.4 ampere. Then V1 is equal to 2 into 6, 12 volt. I1 equal to 2 into 0.4 equal to 0.8 ampere. As per ABCD parameter method, if V2 equal to 1 volt, I2 is equal to 1 by 15 is equal to 0.066 ampere, 7 ampere, then V1 equal to 1.25 into 1 plus 11.25 into 0.067, that is equal to 2 volt. I1 equal to 0.05 into 1 plus 1.25 into 0.0667, that is equal to 0.1334 ampere. If Z1 is not equal to 15 ohms and increase the voltage V1, it will not follow eigenvector. That is V1 is not equal to 2 into V2, I1 is not equal to 2 into I2. ABCD parameters method should be followed. Total power equal to 2 into 0.1337 watts. That is load power equal to 1 into 0.0667 watts. That is 25% of total power. network loss equal to 75%. If we need V1 equal to 6 times of V2, I1 equal to 6 times of I2 for Z equal to 15 ohms, then matrix equal to 3 times of A matrix. A V dash equal to lambda V dash. A matrix Eigen Vector equal to eigenvalue eigenvector. 3 into A V dash equal to 3 into lambda V dash. 3 A V dash equal to 3 into 2 into V dash, that is equal to 6 V dash. ABCD matrix should be multiplied by 3 times. So ABCD equal to 3 into 1.25, 11.25, 0.05, 1.25 equal to 3.75, 33.75, 0.15, 3.75. V1 I1 equal to ABCD into V2 I2, that is equal to 3.75, 33.75, 0.15, 3.75 into 1, 0.067 equal to 6, 0.4, that is equal to 3 into 2 into 1, 0.067. V1 is equal to 6 V2, that is equal to 6 into 1 is equal to 6 volt. I1 equal to 6 I2 equal to 6 into 0.0667 equal to 0.4 ampere. So AD minus BC is not equal to 1. That means determinant of mu matrix is not equal to 1. So it is not possible to calculate mu matrix using eigenvalue eigenvector. Suppose this ABCD network 3 times cascaded connected. That is ABCD mu matrix equal to ABCD power 3. Now eigenvalue eigenvectors are used for matrix power calculation. Initially, we explained about linear regression. ABCD matrix of two-port network can be calculated by using its components of T network, pi network, or by using linear regression method. Eigenvalues, eigenvectors are used for ABCD matrix power calculation. Thank you very much for watching this video. If you need any clarification, you send mail to us. Our email ID is anbu.electric.y@gmail.com.